Hey guys, welcome back to the channel and welcome back to the build of the Kinetix aircraft from ST Jets via Aero Panda. Last video in the build series, we're going to get a lot accomplished in this episode. We are going to do our front end of the aircraft. We're going to install our landing gear and gear system. We are going to do our test run of the aircraft and final setups. So 4 steps to completion. Let's dive in. Aircraft is back on the table and we are diving back into the front portion of the aircraft. After some multiple days of consideration, I think that is our final layout right there. Things could change, we know that. All right, so we got our tray all done here and everything worked out good. What I like to do is if the screws are too long, I just use side cutters and I'll cut them off. I also will put a drop of thin CA in there just to kind of lock everything in place. But we've got everything mounted, so I think it's gonna work out good. All of our cables and power and wires and everything are all gonna come through that center plug. To install the center plug, we just use a step drill bit. And once we get the plug installed, we just use CA to hold it in place. Everything else is just screwed down. The Cortex, I've been starting to install them on a separate plate, so they are more easy to remove, swap between planes, change, stuff like that. And also the Cortex wouldn't like to stick as well to this carbon plate as it would the smooth carbon plate that it's stuck to. All right, great time in the video to bring up today's video sponsor. Today's video has been sponsored by Solder Stick. Now I've been working with Solder Stick for a few months now, I think. Time goes by real quick, and I have absolutely fallen in love with these connectors. They are amazing. I'm all about saving time here at the lighter side of RC, and the solder stick connectors are a huge time saver for me when we're in tight positions on aircraft. It helps out a lot to be able to get into those tight positions. Solder stick, great connectors. They work amazing. They're a huge time saver. You can use a heat gun on them. You can use a lighter is what I generally use most often on them. And something even cooler, guys, Solder Stick has a discount code for all of my viewers. So if you use the discount code RC20 when you check out, you'll be able to get 20% off your solder stick order. Now this case right here is the 500-piece kit. Has all the different sizes in there. The white, the red, and the blue are the ones that I use most often, and they are phenomenal. Now I've done a bunch of test videos on them. A lot of people question the ability of these things to actually work. They work amazing. I've tested them under load. I've tested them during heat and things like that, and they just work phenomenal. So definitely suggest checking out the links down below at the end of this video. In the video description and also the first comment in the video, we have a link to Solder Stick's website. You can use your 20% off code. There's also a cool little heat gun in there as well too on their website. I don't have one yet, but everybody raves about it. It's a small heat gun with a little turnaround thing. I can imagine it would work beautiful in this situation. So definitely check them out, guys. The solder stick connectors get 2 thumbs up from the lighter side of RC. Great product. Huge time saver. I suggest you check them out if you haven't done so already. Thank you, Solder Stick, for sponsoring this video. Let's get back to the Kinetix. All right, so we have been focusing on the wiring, has been the main point of all of this. and trying to get all the wires pre-run. So everything from the back of the aircraft forward, we made sure we got, including our telemetry and PPM lines or throttle cable lines. So now everything from the back is run forward. We put snakeskin on the wires coming forward, and we've got everything in a nice bundle underneath the tray. Now the reason it's kind of important in this aircraft to have your wires fastened down nicely is you've got airflow coming through the bottom intake, and that of course is going to be constantly pushing over the wires and moving them. So I think it's an important thing to make sure they're fastened down. We've got one of our receivers mounted up here, the Rex 12, and we've run the lines for the telemetry from the Swiwen turbine going into the EXT port. And the E1 is our EX bus signal output going into the Cortex. So the only thing we have left to do with wiring in this bundle is put our ends on the ones with the green labels. So that's the stuff from our tail, our rudder, and our two elevators. And then we've got to run everything forward from the nose section. So we've got our two servos, our gear open close to run forward, and our steering servo. All right, so we've got all of our ends on the wires. This is awesome. I love how clean this is going to be. We've got all of our lines done. Everything there is right there, and it's all going to be buried underneath the tray. I think that's absolutely awesome. The front end there, we've got our servo wire plugged in and run. We've got our front gear wire just sitting there waiting for the gear to get installed, so that is great. Primary receivers right there, lines come down underneath the board, so that is wonderful. So we're ready to put the tray in. The only modification we may need to do to the tray is our batteries, right? So if we're putting our batteries on the front tray, we may need to cut some slots for some Velcro straps, or we may put the battery holders in there that we've used on other builds. We'll have to see how the weight and balance all measures out. So next shot, this board will be in that aircraft with all of the wires coming through the through fitting. All right, and there's the tray installed. Went in beautifully, clean and easy. Man, once we get all those lines run, it is going to be phenomenal. Really impressed. All right, so I preemptively made a little foam house for the Cortex gyro. Now, something that kind of happens on most larger airframes that are kind of hollow. When you install the Cortex gyro, a lot of times there's some resonance in there. So when you, this usually happens on the ground, I've found. When you throttle up, you'll see it's usually your rudder. Your rudder will start wagging, and it has nothing to do with the vibration in the fuselage generally. What it has to do with is resonance inside the aircraft, kind of like a drum if you think about it that way. So making the little foam box takes care of that. I just make them out of jetty foam. This is like really dense foam. I know Aeropanda does sell a little cover, but this is the foam that I make mine out of. It's very, very dense stuff. And I just cut it so it's a little bit smaller than the actual shape of the Cortex. So when it just slips over top, it's friction that holds it in place. And then I just cut a little hole, fill that hole with hot glue, and when you turn this on, you can see the light, whether it's amber or red or flashing blue. It shows up really well. And then just to not have to take this on and off for programming, run a separate programming lead out. So this is just an extension plugged into the little learning port there. So if you have to relearn your gyro, you just plug your bind plug into here while you're turning your plane on. So nice little simple solution. The wiring here is very clean. This is basically our wiring for this aircraft. The only other wiring we're going to have to do is our second receiver, which is set up as a clone. So that'll be kind of done into the mix here. And then once we figure out where our batteries are going, we're going to have our power leads coming in there and going wherever they need to go. So that's the only wiring that's left to do, and we're going to clean this up eventually, but we'll wait till all of our wiring is in place before we actually clean that up and zip tie it down and together. So with that stuff done, we're going to move on to the nose door. Now, the nose door, once it's actually glued in place like this, it looks like it's going to be a fairly simple setup. So this servo arm here, this carbon one, brings it right in the center. Again, good pictures in the manual. We want to put a rod system on here with our ball joint, and that rod's going to come down to the side. So our gear kind of tucks in between those two arms, and When this opens, the servo goes down and opens like this, so the rods will be at a bit of an angle coming like that. Okay, so first step with hardware here, we've got some extra, this is 3mm rod. So we've got some extra rod, that's what we're gonna put through the servo arm. We've got a bunch of extra nuts here, so we'll put a couple nuts on there, and then our ball joints will end up like that. All right, so we've got the retract installed, and I installed a spare leg. This is the bull leg is what it's from. And the reason for this is just so we have a reference point and something sitting in there that we know we need to work around. So the gear for this aircraft, I don't know if I've talked about it already, but the gear for this, this Kinetix is the bull landing gear. So I'm taking the landing gear out of the bull. I ordered new legs from Electron, and I think we're using the main wheels and using a new front wheel, but new legs all around because the leg size is slightly different, and that's where this landing gear is coming from. So we've got the gear in there to work around. Now we've taken the, all right, and this is another one of those situations where we're gonna use the Dubro 256 for 440 rod ball joints on the ends here. And reason for that is our mounting points that go onto the door are fairly small, so I don't want to be putting a 3mm Allen bolt through that. I'd like to keep it as small as possible. So same scenario as what we did on the little tiny front door, nose door. And then with something like this, I won't bother doing the high sol trick on the carbon rod. It's just a little door. This is totally sufficient, so we'll just leave these as they are. Okay, so we've got everything just sitting in place here, and I really like this system. It's ultra simple, just having one servo like that. It works really well. I think it's gonna be awesome. So the reason I've got everything just lined up is number one, we need to sand where our fasteners are going onto the door. So I'm just gonna put a little mark on each side, and we'll just sand that out with the Dremel. And that's really the reason. And then what we'll do is we'll tape the doors closed, and we'll get those glued in place with some high sol. Now at this point, I'm not really worried about the position on the servo. Our linkages are what they are. We're gonna use a fraction of the actual travel of that servo arm, so there's gonna be tons of adjustment, and I'm not worried about that. I'm just worried about getting those hinge points or the mounting points on the doors fastened in a good spot. Obviously, we've got a little bit of space on this leg. This leg has a Sky Candy light attached to it, so we do have a little bit of leeway there as well. Okay, so we've got everything ready. We've sanded out our spots on the door there. We've mixed up some 20-minute high sol, and it is time to install this setup. So what we're gonna do is we're gonna get that servo arm screwed in first. All right, so we've got the servo screwed in here. We're just going to move the servo out of the way, and we'll get our high sol installed. Just go around with the high sol and just make sure that we're happy with the amount that's holding those in place. All right, so our whole door linkage and everything is done. It's resting right now. The high sol is curing, so we're just gonna leave that be and leave the plane to sit. Now it's 20-minute high sol. It'll take about an hour and a bit to actually kick off and be firm enough that we can start touching the plane and doing some other stuff. So, all right, I've spent a couple hours here just working on the finer details of everything we've installed. So I'll show you what we've done. We've run our fuel line from the UAT to the fuel pickup on the fuel pump. Goes from 8mm for 75% of it, and then down to 6mm. I just put the joint right here, so it would be contacting the former work. Out of the pump, we come to our 3D printed Festo valve holder, to our fuel filter, and then straight back to the turbine. Turbine's been plugged in. The wire comes underneath. Put a section of shrink tube over top of the wire, folded back and forth. CA'd that to the underside of this brace, so everything's perfectly lengthened and we're not rubbing on the former work, and we've got just the right amount of wire everywhere. So that is the turbine section. We still have to do our fuel and vent lines, that's fine. We've gone and done all the receiver work here. All right, so if you're a Jetty user, this will make a little bit of sense to you, but we've got our Rex 12 as our primary receiver. We've got 2 lines here, 1 line there. So one of these lines going into the EXT port comes from the telemetry port on the Swiwin ECU. We've got E1, which is our receiver output, EX bus output, and that comes down to our Cortex. Then the Cortex goes to our R1 port here. We then have a Rex 3 with the long antennas, and one of those outputs goes to E2 on the Rex 12, and that is set to an input backup, and the other output goes down to R2 on the central box. Theory behind this, I know people won't agree. If the Cortex was to cave, we still have a backup path here with the R3 going directly into the R2 port on the central box. And if the Rex 12 is to cave, we still have that path again going down to the central box. So there's a little bit of redundancy built in there. And then we've got all of our antennas mounted. So the Rex 12 here, we've got 1 antenna there, 1 antenna there. The Rex 3 antennas, we've got another one coming to this side, horizontal, and then the other antenna is right here in this plane. So we've got all 3 axes covered plus the extra one. So that's the detail work we've done so far and all the wiring. Now it's been long enough that our front door setup here is done. It's cured enough that we can move it, and that is super clean. Love that. I think it's going to work out perfect. Very nice setup, and I haven't done any adjustments there yet, but I think that is that's pretty slick. Very nice. All right, guys, so all in all, very clean setup. I'm happy with this. I love the fact that everything is so neat, tidy, and clean, well spaced out. Obviously, once we get the batteries in there, that'll change things a little bit. Next thing I'm going to mount is my remote switch, which is the switch that we can use the transmitter to turn everything on and off. And we're just going to have that sitting down here, probably right in this area on the primary board with a nice short little cable. So we'll get that installed. That's really not a big deal. And then what I'm going to do is I'm going to program the nose door here, and we'll get that done as well. So I'll take you along on these steps. All right, guys, so we've got the doors programmed. Obviously we don't have the leg yet, so I'm hoping the way this works is when the gear's down, the leg's coming through here, and the main doors close. I think that would be awesome, because that means we're not gonna let it get any grass or much grass at all sucked up through the nose area. So I will raise the gear up and I'll show you what it looks like here. So gear up, doors open, and it's going to take a while when there's no gear attached. That's one of the things, is this delay. Keep that in mind with Electron. If the gear is not attached, it does take a while. So that's gear up and then gear down. So gear would come down, and then after a little bit here, it will close the main doors. There we go. All right, and our final steps here are completed. So we've got all of our plumbing done on the fuel system. We have filled our UAT full of fuel, and it's always nice to keep these full of fuel so your element isn't exposed to air, because then you get air bubbles stuck in there, and when you run your turbine, it tends to suck that air up. So I always leave this full, and it's kind of the way it goes. If you're draining the fuel system out, it won't drain this unless you really have to, because it's pulling from this nipple right here, which is the highest point. Yeah, fuel system's all done. We ended up installing the filler that I like to use right on the top here. I was a little skeptical of drilling through this carbon. It's kind of the support for the top canopy area, but I don't think this is going to be an issue. And rather than going in the center here, I went off center, so there's more material. So not worried about that at all. And that is it. We've gooped all of our connectors everywhere. We've cleaned everything up, zip tied everything. This loose lead right here is our programming lead for the Cortex, but otherwise that is set. So as of right now, we're gonna put this on pause, and the video is not gonna seem like anything, but we're just waiting for our gear to show up. It should be here in the next day or two. When it's done, we'll continue. So for you guys, it'll be like a couple seconds, but we'll see you when the gear arrives. All right, so we got our order from Electron, and this is exciting. So there's a couple things in here, a little bit of extra stuff. We've got our, those are our axles to hold the main wheels on. We've got a set of Electron servo arms. Now I'm really excited to try these out. I've been kind of eyeing these things up for a while. So we're not going to use it on the Kinetix, but we will definitely use this in the future. Very nicely machined, very impressive looking servo arms. Those are super cool. And then we got a set of ball joints here as well too. So again, these come in different sizes, but we got M4 ball joints, and those are pretty darn cool looking. So exciting stuff. I think this is great new products from Electron. These are all aluminum as well. Brass insert, really, really nice. We've got our nose pin here. We've got our nose leg, two main legs, a new motor unit because we are using the retracts from the Bull, and one of the motor unit plugs got a little bit damaged. Still works, but I want to replace it anyways. Inez. And we've got a new front wheel. So we'll compare all these to the Bull ones just so we have a reference point. They are different in length though. All right, so here's our Bull front leg, and the stock Bull wheel is 75 millimeters. The Kinetix front wheel is 70 millimeters, so 5 millimeters difference. So there's our Bull leg, which is 74 actually, and there it is compared to the Kinetix one. So really hardly any difference at all. Yeah, but this is the right one for the Kinetix. We've got the nose leg. So you can see there, substantially different on the nose, quite a bit shorter. Obviously the silver one's the Kinetix one, the black one's the Bull one. So very, very different there in length. And the main legs, not really a big concern, but those are the main legs. So the one thing that we reuse from the Bull is we reuse the main wheels. Now those main wheels are fairly large. I think they're 3.5 or 4 inches, but anyways, we're using the Bull main wheels, and the front wheel is the new one. Now the only downside, the Bull main wheels are black. This nose wheel will be silver. I don't really care about that, but some may. Okay, so what we're gonna do now is we're gonna get all of the stuff ready to install. So as per normal, we're gonna make sure everything gets Loctited. We've got a reflat spot stuff. Now the nose leg here, because we've already got flat spots that are all perpendicular to the servo arm, we can just reuse this exactly the way it is. I'm going to put a piece of carbon over top of that linkage arm though. Our mains, we've got new pins for the mains. So we have to flat spot the new pins on the mains to make sure we get the right toe in. All right guys, we got all the gear assembled here. Really nothing surprising. Everything's very, very normal. And that's good. So we've got one of the wings down here. This is the left wing, and we're gonna get the gear installed now. Now, one of the things to think about is, unless you have the aircraft all assembled, how do we know where our 0 point is and we're angling and calculating toe in? I think this definitely qualifies for a tip time, and this tip time is brought to you by Trusty Bent Screwdriver. So this tip time revolves around finding out if this wing root is parallel to the flight line. Very simple. Take a square, stick it inside the wing tube, and you'll see if the root of the wing is square. So why this matters is if we're setting the toe in on our main gear, we don't have to assemble the plane and get everything done. All we have to do is transfer this mark somewhere closer to here with measuring over, and then we can just use the root of the wing as our reference point for toe ins. That will be parallel to the center of the flight of the aircraft, or the center line of the aircraft, and we'll add a couple degrees of toe in. So we're also using our shop extensions here. This was last episode's tip time, and this makes things so much easier to get our GS200, which is in the aircraft already, run over here so we can cycle this gear and get it set up on the wing. Okay, so we've got the gear installed. This wing is very nice, very easy to work on. Lots of room in here. So all I do is get the gear kind of set up, pre-adjust the angle a little bit, and then we just go through and cycle the gear and just check our position. These openings for the gear are very, very accurate. So there's actually very little side-to-side play or rotational play on the gear. And I think I'm very happy with how that looks. Okay, so we've got everything marked here. We've got the gear kind of set up. Everything's good. We're happy with everything. So we're going to drill one of the holes out. We are using wood screws to mount the gear. Yes, I know. Some people don't agree, but that's okay, because you're not me. I prefer wood screws in this situation on a serious note. The wood screw actually fits this hole perfectly, and the carbon and wood that we're screwing into is 1/2 inch. So just crazy strong. No issues with that at all. So now we've got one screw in there, which is enough to do our testing. So now we can get everything set up. So what I'll do at this point is I'll pull our angle screw out because we need to Loctite that. And we'll get that all adjusted and set up now. Beauty, I think that is perfect. So we'll back that off just a little bit. And I think that is good. Awesome. So that's the installation of the one side here. So now what I'll do is I'll drill out the other 4 screws. We'll get those screwed down, and then we'll set our toe in. And once that's done, the gear is basically installed, other than running our lines. But this is kind of the steps to go through to set up your geometry first. And then after that, we'll worry about our line setup. Okay, so I've got the toe in built into my leg. So what I did was I had the leg installed, took a carbon rod here, lined it up on the tape line, and that allowed us to screw in the screws and get our marks set up on the leg itself. So I've gone ahead and sanded one of my marks down. And what I'm doing now is I'm going to reinstall the leg, and we will double check our toe-in setting. Okay, so if I take my carbon rod here, I'll try and show you guys this. You can see there, if we line it up with the edge of the blue tape, we've got just a couple degrees of toe-in. So nothing too crazy. Happy with that. So what I'll do now is we need to run our gear line. Now the gear line on these gear are crazy simple. We go from right here through the hole to this location right here. So that's a really short little run. The brake, I love this setup as well too. This is my favorite way to do the brake. So the brake is going to come down, go this way behind the gear, and then come out through that little hole where the rest of them have come out. So it's going to be uber simple on the brakes as well too, and then it's a straight shot over. So really simple setup on this Kinetix. That is super cool and easy. All right, so right wing is done. We've done all of our wiring here as well, and we just followed the exact same pattern as what we did on the fuselage side. So straightforward, that's done. Again, when we put this wing together, all of the excess is going to sneak inside the wing. So now we'll do the same thing on the left wing. We've got our nose leg installed. That turned out really nice. That's actually really easy to install. Zero problems. And there's a shot from the inside. Because this servo was the one we used in the Bull, this whole setup is, I just kept everything the same. The only thing I had to do was put a couple wraps of electrical cable or electrical tape over top of the sheeting here and just glued that down to the actual servo. Reason for that is when I was retracting the servo the first time and then coming back out, the cable was getting caught on the nose door servo. So this keeps everything out of the way and good. Here's a shot of the nose gear doing its thing. Perfect, so that's up. Doors are going to take a while because it's not registering the mains. And here's gear down. And then the back doors close. So that means our gear installation is complete. Let's put the wings on. Gear up. Oh, that looks better. And gear down. Awesome. So I added 1 second delay on the nose doors on both ends just to make sure that the gear wasn't going to hit the door. It was really close when I first installed it. All right, guys, well, it's time to put her on her own legs for the first time. We got her pretty much full of fuel and we're ready to do our test run here. All right, so we got all of our safety gear here. We've set up the turbine and we are ready to test run this thing. So we'll go through the normal test procedures. We will check, we'll let it settle to idle. We will do our acceleration test and adjustment, and then we will be doing our restart test and those kind of things. So as we go through this, I will pop up on the screen exactly what we're doing. Now I've already primed the engine, almost back to the engine. We've got about 6 inches of empty fuel line. Just getting the fuel line to the turbine, or the fuel to the turbine in the fuel line. There we go. All right, so great running 240 engine. The initial acceleration when I was at the numbers that they come from the factory are usually 25 and 25 for the acceleration and deceleration. At 25, it was 3.8 seconds. I dropped the number down on acceleration to 23, and that made it go to 4.2, 4.3 seconds. So I've moved it back up to 25, so it's about 3.8 seconds, which is very fast, but it's working very well. It's gonna be a lot of power for this plane. All right, so last thing we have to do on this aircraft is to get the CG done and get everything set up. We've got two ways that we're gonna CG this aircraft. Number one is the stock templates, which are gonna make this very easy. And then just for fun, I like to double check the CG and use our RC CG machine with our Zycoy balancing scales, because I love using this device. All right, so with regards to the CG, it looks like we are gonna end up with all of our batteries, so 2 receiver and turbine batteries right on the front part of this tray. So what I did here was I had this battery bundle from the Super Elan that weighed as much as my 2 receiver batteries that are coming, plus 25 grams. I needed some extra weight, so I put my quick release removable battery trays. These are from Joe from RC Custom 3D Printing. Thank you, Joe. And our turbine battery is right there. So our 2 receiver batteries will go in the double, turbine battery will go in the single. We are going to install the cockpit tray, and we've got just a tiny little bundle of nose weight needed. So this is our nose weight needed here as it sits right now. Now we have to run our wiring and plugs, so we may actually end up not needing any nose weight. But on this aircraft, if you're building it with a cockpit and there's gonna be a pilot there, then you're probably gonna run your receiver batteries on the tray and maybe your turbine battery in front of the tank, which is kind of where I thought I would be running mine. But because we don't have any pilot, that's not adding any additional weight to the nose section. So our batteries are on order. Now that we know the weight of our batteries, we can get our trays installed and work on our wiring for the turbine and power system. So we've spent some time today getting the CG set up, and I know I initially talked about using those battery holders, but they actually were a little bit too big, so I tried to put them side to side. And ultimately what made them too big was just not being able to use battery plugs. I really like to use battery plugs mounted in the board. So I went with the standard setup with Velcro underneath the battery and a strap holding it in place. Now these aren't the batteries we're using, we're just using them for weight. We actually borrowed these ones from the Red Hawk over there, and we're just using them because they're almost exactly the right weight for what we're looking for. This battery is the correct battery. So the tray is currently out right now. I'm just waiting for the high sol to cure around the plugs, and we'll be able to put this back in place. So right now, the CG's done. We've added a little bit more weight in the nose because of that. So I don't know how many ounces or grams or anything like that, but that's how much weight we ended up in the nose. That's good because that'll allow us to be able to remove some as we feel more comfortable with the plane and move the CG back appropriately, of course. All right, and our final thing to get done here is our programming travel adjustments. We've got some great travel adjustments here, and this should be a great start based on what I can see. So we're gonna go into the radio and do all of our surface adjustments based on the manual, and we'll give our final remarks. All right, guys, and that wraps up the Kinetix from ST Jets and also from Aero Panda. We did do a final weight on this aircraft, and I was actually pleasantly surprised. So it came in at 36.1.2 pounds. I was actually expecting it to be closer to 38. So that is awesome. The lack of a cockpit and pilot figure definitely help to keep that weight down. This airplane is going to be an absolute hoot with the Swiwin 240 engine. Thank you to MKS Servos for providing the servo package for this aircraft. Thank you to Electron Retracts for helping me out get the parts and everything to make the kit work. I appreciate that. The Swiwin turbine came from us, from the lighter side of RC. The kit, of course, came from ST Jets. Sergio Tiesta, amazing kit. This is definitely a work of art. I love the finish on this kit. It was amazingly simple to put together. The custom logos everywhere on it. Beautiful aircraft. So that final weight was with the batteries installed, CG all complete, UATs full, no fuel on board. So it is going to be an absolute rocket ship. We may turn the engine down, we may just use that throttle stick even more. So the maiden flights will be coming up soon, so stay tuned for that, guys. Very soon in the near future, we'll be getting the first flights on this aircraft. Thanks so much for watching the Kinetix Build series. If you're interested in this jet, gets my thumbs up of approval, that's for sure. Definitely 2 thumbs up. This is a phenomenal aircraft, and I guarantee you will enjoy building it and you will love flying it. So we'll report more on that once we actually fly it. Thanks guys for watching, and we'll see ya in the next episode.